If we have, as a general rule now, for any polynomial of the form ax raised to power n, where n is an integer, it can even be a fraction, you know. So if we differentiate y with respect to x, what we get is n times a x raised to power n minus 1. Please bear this formula at the back of your mind. It is helpful. Instead of resuming the derivative from the first principle, anytime you find a function that is of this form, you apply this formula and then you get the derivative. For instance, you know, if I give y to be minus 6x raised to power 5, and then I say find dy by dx. By applying this formula, we simply have, so using dy by dx is nax raised to power n minus 1. We identify who our a is in this problem, who our n is in this problem, and then we fix in. So you can see that our a is minus 6, our n is 5. So we simply substitute here, so we get that, so dy by dx is nothing but, n is 5, so 5 times minus 6, then multiplied by x raised to the power 5 minus 1. This is nothing but minus 30, x raised to the power 4. So dy by dx is minus 30, x raised to the power 4. So you can see how simple it is to apply that. So it just follows from here and then we get what we want. What again, if I give y is, say, half x raised to the power 1 over 3, we can still apply this formula, and so dy by dx is nothing. Our n is 1 over 3, our a is half, and so we have 1 over 3 multiplied by half, x raised to the power 1 over 3 minus 1. And this is 1 over 6, x raised to the power, this is 1 minus 3 over 3, and this is 1 over 6, x raised to the power minus 2 over 3. So the derivative dy, in this case, by dx is simply 1 over 6, x raised to the power minus 2 divided by 3. So you can see how friendly and easy it is to apply that formula to compute the derivative of any function we can identify to be of that form. Okay, so we have dealt with some varieties of some types of functions and have seen how to deal with the derivatives. Now, if you have been following my channel, you would have seen when we introduced functions and then we dealt with operations on functions, where we saw how we can add two functions to get another function. You can multiply two functions and get a new function. You can divide a function by another and get a new function, and so on and so forth. So this time, suppose we are faced with such situations where we have the sum of two functions that gives a new function. How do we compute the derivative of the new function? If I have two functions I multiply to get a new function, how do I compute the derivative of that new function? If I have a function composed with another function, how do I compute the derivative of the resulting composite function? And so on and so forth. So this leads to what I'm going to discuss next, which is what we call the different rules for differentiating different functions. And so that's the next thing to consider.